You know, when you think about leather, you probably picture this ancient, timeless craft, right? Something rugged, something born from skilled hands and long-held tradition. But what if that's only half the story? What if I told you that behind every great piece of leather, there's a story of precise, sophisticated chemistry, a science developed thousands of years before the first modern lab? Okay, let's get into it.
Because that really is the question, isn't it? Is leather tanning just this traditional art form passed down through the generations? Or is it one of humanity's oldest and frankly most successful experiments in applied chemistry? And when you start digging, the evidence is, well, it's pretty stunning.
So, just to make sure we're all on the same page, tanning is essentially the magic trick that turns a raw, perishable animal hide into the durable, flexible material we all know as leather. And the secret to that magic? It's all chemistry.
And this chemical know-how goes way, way back. I mean, forget about medieval guilds for a second. We have to travel all the way to the dawn of civilization. Because these ancient artisans weren't just tanners, you could honestly argue they were some of humanity's very first industrial chemists.
Our first stop is Mesopotamia, around 1400 BC. The Mitanni people left behind what we believe is the world's first ever recorded recipe for tanning. And when you look closely, you realize this isn't some list of folk remedies. Oh no, this is a multi-stage chemical protocol.
And this recipe, it reads like a modern chemical process. Seriously, each step logically sets up the next. They'd start by preparing the hide with enzymes to break down stuff they didn't want. Then they'd buffer it with oils to keep it from getting hard and brittle. But the real science kicks in with step 3, adding alum to stabilize the molecules. And for the grand finale, they'd fortify with tannins from oak galls for a tough, heat-resistant finish. This was not guesswork. This was a precise, repeatable formula.
But here's what's so cool. This wasn't the only way to do it. Thousands of miles away, on a completely different continent, indigenous peoples in North America were getting the same results with a totally different scientific approach. And this one came from the animal itself.
They perfected a method we call brain tanning. The key ingredient is a molecule called lecithin, which you find in animal brains. Now think of lecithin as having a two-part personality. One end of the molecule absolutely loves water, and the other end loves oil. This unique structure makes it a perfect emulsifier, letting it coat all the leather fibers and make them incredibly soft and water-resistant. Just brilliant.
And this just illustrates the point so perfectly. You've got two ancient cultures, zero contact between them, and they each developed these distinct, highly effective chemical strategies. One, a mineral and plant-based process where you're adding things in stages. The other, a biochemical process using the animal's own body chemistry. Both were pure science, figured out through deep observation of the world around them.
Okay, now let's see how this idea builds, because sometimes the secret chemical ingredient wasn't something you added to the mix at all. Sometimes it was already there, just waiting in the environment itself. And for that story, we've got to go to Florence, Italy.
For centuries, right, Florentine leather has been seen as the gold standard, the best in the world. And the assumption was always that it was all about secret family techniques. And yeah, that's part of it. But the other part, the real hidden advantage, it was the unique chemistry of the local water supply, the Arno River. See, the Arno is what we call hard water, which just means it's packed with calcium and magnesium ions. So what, right? Well, here's the thing. These ions act like tiny little molecular magnets. When the Florentine tanners soaked their hides, these ions would form these little bridges, helping the plant tannins they used to latch on more tightly and more evenly to the leather's fibers. This gave Florentine leather its signature deep color and amazing durability, a built-in, repeatable advantage, all thanks to the local geology.
But listen, the Florentine masters didn't just get lucky with their water. They understood their materials on a profoundly deep level. They weren't just artisans, they were chemists, with a whole library of natural ingredients at their fingertips.
I mean, just look at this toolkit. It's like a pharmacy of organic chemicals. These tanners knew exactly which plant to prescribe for a specific result. You need a firm texture? Okay, use chestnut. You want a super smooth surface that's perfect for finishing? That's sumac. For serious hardness and heat stability, you turn to quebracho. This was not random. This was precise formulation.
And this meant they could create custom recipes, you know? They would literally blend these different tannins together like a master chef or a pharmacist to precisely control the final product. For a hard, durable leather, maybe it's a mix of mostly chestnut with a bit of oak. For something soft and flexible, they'd focus on sumac. This is pure, goal-oriented chemistry, plain and simple.
So what does all of this, the recipe from Mesopotamia, the brain tanning in North America, the Arno River, what does it all really tell us? Well, it points to a much bigger idea about how human knowledge actually develops.
And it really all comes down to this idea right here. Today, we want formal, scientific proof for everything. But for pretty much all of human history, culture and technology were built on what you could call empirical wisdom. Knowledge you gain through generations of observation, of trial and error, perfectly adapted to the world right outside your front door.
And leather tanning might just be the perfect embodiment of this incredible legacy. It's a powerful reminder that science doesn't only happen in a lab with beakers and white coats. It happens out in the world, passed down through generations of careful observation and practice.
Which kind of leaves us with a fascinating final thought, doesn't it? If this level of chemical sophistication was hiding inside an ancient craft like leatherworking, how much other hidden science is still out there waiting to be discovered in all the things we've always just taken for granted?